So I am not going to draw 8 boxes on my board, or you wouldn't be able to see that big. So each one of my boards, I'll turn the page every single time, is just one of your rectangles. Does that make sense? You'll have plenty of room to write. Every now and then, when I'm going to tell you to do something, and I may have a little bit of something extra to write in your box. So I wouldn't write ginormous, but I don't think you even have to write small. Like, I think whatever you do is going to be fine. So I'm going to give you this first one. We're going to start off complicated. Or anything. I want you to factor this. So x squared minus 16x plus 64. Okay, I know, it's super hard, right? This is a review, so this should be easy today, right? It should be actually be halfway boring you through most of it. Not that I want to bore you, but there's some things. Huh? What if it's all the way boring? Maybe, you know. Then if it's all the way boring, that's actually not a bad thing. That means you know how to do all this. But all right, so this is not difficult to factor, right? Who wants to tell me what you get? No, go ahead. You can give me that. What you got? Okay, x minus 8 times x minus 8. Anybody have anything different? X minus 8 squared. Okay, so if you got to this point first, there's absolutely nothing wrong with that. But if you got to this point first, that tells me that you most likely factored like you would factor anything that I would give you. Did anybody get to this point first? Like you just jumped straight to this? Okay, you did? Or are you lying to me? You can see what they did? Okay. And it's okay either way. Like it doesn't matter either way, but if you do it this way, it's got to end up here. You remember this page here? It's page 27 in your ISN. Turn to page 27 and keep this handy. I want you to look at it. Because this is a special case, right? What is this called? Perfect square trinomial. Okay, so this is a perfect square trinomial. Right? Perfect square trinomial. So what that says on there then is if I have, excuse me, if I have x squared minus 2xy plus y squared, then that equals x minus y squared, right? So this is what it says on your little flowchart thing. With that being said, the x up here and the x up here, or down here, are the same thing, right? What would y be up here? 8. Y would be 8, right? So if I wanted to write this in this form, which you don't necessarily have to write it in this form to get there. I just want to make sure we all understand where it's coming from. This is like x squared minus 2 times x times 8 plus 8 squared. If you have something in that form, then you don't have to go through the factoring process like this. You just know exactly what it is. So if this a is 1 right here, and you can take half of this and square it, it's a perfect square trinomial, and boom, there you go. Okay. Not that factoring it this way is even that much more difficult, but if a is not 1, it might be good to recognize that, or whatever. Okay. We all good with that? All right. So then let me give you number 2. Go to the next box. Number 2. 4x squared minus 12x plus 9. Is this a special case? Maybe. I think it is. Can you take the square root of the first term and the square root of the last term? Yes. The square root of this term right here is what? 2x, right? So this gives me 2x. This gives me 3, right? Is this one right here? So that's 2x squared. This is 3 squared. Is this minus 2 times 2x times 3? Yes. Yes. So then, is this a perfect square trinomial? You see how it fits that same pattern we just looked at? This is the x squared minus 2 times x times y plus y squared. So that means then, without doing any grouping or anything, what goes in here? 2x minus 3. Now, if you don't understand the pattern very well and you don't recognize it, you don't have to, okay? But the shortcuts and the special cases are nice if you can recognize them. I think you are way more likely to recognize them when a is 1 than when a is not 1. But if your numbers get a little bit crazier, I mean, yes, I can multiply 4 times 9 and then I can factor doing grouping. There's absolutely nothing wrong with that. You should actually be pretty quick at that by now because that should be something that you're good at. So it's fine to do it that way. I just want to remind you that there are special cases and there are times when this could come in very handy if you understood it. Okay? We good with that? All right. So let's look at number 3. Go to the next box. 3, I'm going to give you 4x squared y minus 36y. And then I'll give you a second to get that factored or at least get it started. Does this include a special case at some point? What should always be the first thing we look for? GCF, yes. Okay, and so what I noticed last period is some people factored out the GCF, some people just factored out the CF, right? There's a difference between those. CF would just be a common factor. Because you can be a common factor and not be the greatest common factor, right? You can factor things sometimes without factoring out the GCF. And sometimes it makes it harder to factor. If you're solving it, your answer in the end would be the same. But if you're supposed to factor it all the way, then if you don't factor it out at the beginning, you got to factor it out eventually anyway, and it's way easier to factor out at the beginning. So what's your GCF? 4y. Good. So your GCF is 4y. So 4y, and then that leaves me with x squared minus 9. Right? If you just factor out the y, you can still go farther, but then in the end, you got to do some other stuff too. So can I factor this? Yes, what's that thing called? Difference of squares. Okay, so difference of squares. So if I have a squared minus b squared, then that just gives me a plus b and a minus b, right? Does it matter if the plus or minus comes first? It doesn't. So then I end up here with 4y times, this is a perfect square, this is a perfect square, right? So x plus 3 times x minus 3. I think the little flow chart has the minus come first, but it really doesn't matter. I don't know, I always put the plus first for the reason. And that's factored all the way. Everybody okay with all that? We good? Review, yes? Awesome. Then I want you to do number 4. This is 16x to the 4th minus 1. Get that one factored completely. Is this a difference of squares? Yes. Okay, so we get 4x what? Squared minus 1. 4x squared. I just said I always put the plus first and then I put it second, but it doesn't matter. I guess I'm not consistent like I thought it was. Who knows? But but either way is fine, right? So am I done? No. Can I factor this some more? Yes. So I can factor this into 2x plus 1 times 2x minus 1. Can I factor this anymore? No, I cannot. So that stays 4x squared plus 1. Can I factor any of it anymore? Or combine it together? Nope. So I am done. That is it. Make sure that you don't stop after one process of factoring if you can keep going. Okay, we all good? All right, so number 5. T cubed plus 125. See if you can get that factored without looking at your little flow chart. Then you can look at it to check yourself. But what's this called? Something of cubes. Not the difference, but the sum. Okay, so this is the sum of cubes. And there was an acronym that I talked to you about when we first glued this in that I think most of you hadn't heard yet. But remember, it was SOAP. So if I look at this, my pattern here with A's and B's, for the sum of cubes, I'm going to end up with a binomial and then a trinomial, right? And so if I start with A cubed plus B cubed, right, if that's what I have, then this is A plus B. This is A squared minus A times B plus B squared. There's no 2's or anything in here. It's just all A's and B's, first term, second term type of thing, once you take the cube root. This sign right here is always the same as what you're factoring. This sign is always the opposite of that. And this sign right here is always positive. That's where SOAP comes from. Same, opposite, always positive. Because if you can get the A's and the B's in there, the A's and the B's look the same for sum and difference of cubes. And then the signs, you just figure out from SOAP. Because the signs are most likely what you get wrong and backwards if you mess anything up. Maybe you don't mess it up at all. But so doing that, if I can take the cube root, both of these, then I'm good. I'm going to end up with something that looks like this, right? So the A here is T, so this would be T plus what? 5. And times T squared minus what? 5T plus 25. And we're done. Okay, we good? Yes? Awesome. All right, number 6. I'm going to give you a minute to work on it on your own. 64 minus 27x cubed. Is this a special case? Yes. Do you know what the cube root of 64 is? 4. Okay, so let's say that you didn't know. You didn't know what the cube root was, or you weren't sure that it was a perfect cube, right? If you weren't sure, but you kind of thought so, my guess is you probably would just do kind of guess and check, like it's probably 4, and then check it yourself, right? But let's say it was a number that you either didn't know the cube root of, or you had to simplify a cube root. Do you know what to do in that case? Okay, would you know what to do if you had to find the cube root and you don't know what it is and you don't have a calculator? Would you know what to do? Yes or no? Yes, some of you yes, some of you no. Okay, so let me use for the no people, because I want to remind you of this too. I'm not saying you would have to do it for 64, because really you should know what the cube root of that is. But if you had to simplify a cube root, or you didn't know what it was, if you can simplify a square root, you can simplify a cube root and a fourth root and all the rest of that. So little kind of side note to this. If I want to take the cube root of 64, I first start off ignoring the fact that it's a cube root, and I do my little factor tree just like you would for a square root, and just like you learned in elementary school when you did factor trees, right? You can make this 8 and 8, or whatever, 2 and 32, it doesn't matter. And then 8 can become 2 and 4. So 2 is a prime number, 4 becomes 2 and 2. Then this 8 becomes 2 and 4. and the 4 becomes 2 and 2. So it just looks like when you first learned the factor thing for square roots as well, right? The difference is I'm not looking for a square root, I'm looking for a cube root. So instead of looking for two things that match, I'm looking for what? 3 of them. So these 3 2's get to come out as a regular 2, and these 3 2's get to come out as a regular 2. If I had anything left over, it would stay under the cube root, like if I was reducing it, right? But then this just gives me 4, which we probably already knew was the answer. Just like with square roots, you don't have to go all the way to the end of your trees. When you get to here, and you know you can take the cube root of 8, you can stop there and just take the cube root of 8 is 2, cube root of 8 is 2, that's where you get the 4 from. Does that make sense to you? So just, I want to make sure you know how to simplify roots that aren't just square roots. It's the same concept, you're not looking for pairs, you're looking for sets of 3 or sets of 4 or whatever it is. Okay, but either way, yes, it's 4. And this is the difference of cubes. So that means as far as my signs go, it's the same, it's opposite, it's always positive, right? Same, opposite, always positive. Cube root of 64 is 4. What's the cube root of 27x cubed?
3x.
3x. Okay, so then here, this is a squared, so this is 16 plus what? 12x plus 9x squared. Okay. All right. Everybody good with that? Any questions? Awesome. All right, number 7. 20x cubed minus 5x squared plus 8x minus 2. Is this one a special case? Maybe. What all are your special cases with cubes? It's just sum and difference of cubes, right? So if this is a cubic and it's not a sum or difference, it's not a special case. Is there a GCF? No. Could we factor this maybe? What process would we use? Grouping. Good. So we have these in descending order, the exponents, so then I can use my grouping here, right? So I factor out, what do I factor out the first 2 terms? 5x squared. Good. And that leaves me with 4x minus 1. Then what do I factor out of this? 2. So plus 2. And that leaves me with 4x minus 1. And then I want to pause here for just a second. I want to make sure you know what this is called. Okay? This right here, this 4x minus 1, this, do you know what it's called? Anybody?
No.
Okay. It is a factor, though, yes. It is a common binomial factor. And because it's a factor, that's why you get to factor it out, and that's why grouping works, right? But that's called your common binomial factor. It's not like the GCF was this 5x squared, that's just a common factor. This is a common binomial factor because it's possible that a problem, and it's not necessarily just always going to be a factoring thing, but they could start you at this point. And I would pretty good money that a lot of you, if something was given to you at this point, the first thing most of you would do would be to distribute what you could in there because, ooh, I can do some math and I can distribute. Because that's what y'all do. You just jump in, you start doing math that you can do, and you're not really focused on what the heck is even going on and what your purpose is, right? You just start doing stuff. Then you worry about what to do, and then you're like halfway into it, and then you're really confused. But at this point, sure, I can factor that in if that's what I needed to do. But if I'm trying to solve this or factor it out, me distributing that back in is just going to get me right back here, which means I'm going to have to go right back here, right? So since that's a common binomial factor, that's why you do the next step of grouping, which would be to factor it out and get 4x minus 1 times 5x squared plus 2, okay? So just know that you could start something, if you start something like that, you're basically halfway through your grouping process, right? It's done for you. And then can I factor this anymore? Nope, good, done. All right, any questions? Number 8. 9x squared y minus 8x squared minus 9y plus 8. Do I have a GCF? No, not a special case, right? So what do I need to do? Grouping, so my group and my group. What do I factor out of the first 2? X squared. So that leaves me with 9y minus 8. What do I factor out of the next two?
-1.
-1. That's very important. -1. And that leaves me with 9y minus 8. Then I get 9y minus 8 times x squared minus 1. Oh, wait. There's more. Can I keep going? Yes. I can't factor this one anymore, 9y minus 8. But I can keep going with this one. This becomes x plus 1 times x minus 1. Then can I go any farther? No. Good job. All right. Just make sure you keep asking yourself, am I done, before you say you're done. Now, I want to remind you that of this, too. Like here, you have to always factor out that negative. You know that. You should know that. If this was positive and this was negative, so basically I had nothing to factor out, you still have to factor something out. What would you factor out? +1. It's like the only time where you actually factor out a +1. Otherwise, it's just a waste of time, right? But it's important there, or you get confused and do weird things. Okay, so now your paper, you have your paper, you've been writing on it, right? Because we want it to work in our ISNs the correct way, we don't want to flip it over like we're used to flipping over a piece of paper. The best thing for you to do maybe, so you're not all backwards and confused, if you're looking at it this way, just fold it halfway up like that, and then start writing right here, and you know it'll be upside down correct in your ISN. Because remember, it's upside down from what you're used to. So I was here, it was all flat. Here's my 1 through 8, except my numbers are wrong, so don't look at my number. And then I fold it up like this, and then you can start right here. And then you can open it up after you start there, so you can make sure you open it. Either that, or you can just take it and flip it like that. It's the same thing. All right, and then we're on number 9. Number 9. P cubed minus 5p squared minus 6p. All right, so get that one factored. Is this one easy or difficult? Pretty simple, right? Is it a special case? No, but what do I have to do first? GCF, yes. Just because it's a cubic doesn't mean it's going to be weird, right? So p squared minus 5p minus 6, right? And then if I can factor it, it's going to look something like this. This is negative, which means my signs are opposite, right? So one of them is positive, one of them is negative. And what are my two numbers? 6 and 1. Which one's positive? 1 and then 6. Does it matter which one comes first? No. Okay, so this should be a piece of cake for you. All right, number 10. 3b squared plus 11b minus 4. So is this a special case? No. Any GCF? No. Now there's multiple ways you could have been taught to do this. I really would suggest that you're consistent with what you do in grouping, since you have makes the most sense, right? So 3b squared, and then I would have to split this term. 3 times 4 is 12. So they have to multiply to give me 12 with the opposite signs and combine to give me a positive 11. So that could be what? -1 and, -1b, which I guess I really just could have put -b. -1b or -b, whatever, plus what? 12b minus 4. Or could I put the 12b first? Yes, as long as b positive is fine. So what can I factor out of this? B. So b times 3b minus 1 plus what? 4 times 3b minus 1. Okay, so 3b minus 1 times b plus 4. Everybody good with that? You should be rock stars at this. If you're bored right now and thinking, why the heck are we even going through this, that's a good thing. If you don't know how to do this quickly and easily, you need to go spend some time on Khan Academy, because you should have been put through the ringer with this stuff, and it should be a piece of cake. Okay? All right, number 11. X cubed plus 2x squared minus 25x minus 50. You agree with me so far? Am I done? No. This is difference of squares, so x plus 5, x minus 5. Now am I done? Yes. Yes. Okay. Always make sure you can keep going. Don't make stuff up, because maybe you can't keep going, but you keep going when you can. We're good? All right. Next one. 12. X to the 4th minus 3x cubed minus 27x plus 81. Okay, let's go ahead and factor that one. Y'all are all still writing, so that's a good thing. That means I can't stop here, right? All right. Okay. Okay. Can I stop here, or do I need to deal with something else? I need to do one more thing, right? What do I need to do? X minus 3 squared. Then I'm done. That's why that one was on there. So you had to keep going with the cubic, and then if you have common terms there, make sure you put them together. Okay, we all good with that? Yes? We're experts at all this stuff? Yes? Okay. Only 2 more. We're not filling all the boxes. 49 x cubed minus 14x squared minus 7x plus 2. You agree with me so far? Can I go any farther? Yes? What could I do?
7x squared minus 1 can factor out.
To what?
7x plus 1 times. Oh, no, it can't. My bad.
It's okay. That's one reason why I put this one on here, because I don't want you to think every time you can keep going farther, because you can't. In this case, I can't go any farther, and that's okay, because not everything's a special case, but I can get it factored. That's the best I can do right now. Doesn't mean I can't solve it, but I can't really get it factored nicely anymore. We good? All right. 14. X to the fourth minus 5x squared plus 4. So when you start this one, although it's a fourth degree, what do you just treat it as? Well, like a quadratic, right? I know what you meant. You just treat it like, because you can factor quadratics easily. So I just treat it like a quadratic. I'm going to be able to factor it. So this isn't x and x. This would be x squared and x squared. And as long as I do that, everything else is fine, right? The signs have to be the same because this is positive, so they're both negative. And it's just -1 and -4, right? But then am I done? No. This becomes x plus times x minus 1 and x plus 2 times x minus 2. Everybody good with that? Yes? Factoring is fun, right? Yes, it's like little puzzles. I said it last period, and somebody gave me a dirty look. Don't give me dirty looks when I say factoring is fun, because you know it is. It is fun. It's like little puzzles. All right, so the assignment. But the thing is, it takes some practice, because even when we're good at it, we understand it. If this is like a piece of cake to you, then you should be able to knock this out quickly. Don't just use an app and get the answer. Like, actually do it. And if you can't do it, figure out how to do it, because this should be a no-brainer for you, all right? Don't be lazy. You know who I'm talking to. Not just Juan, but a lot of you. Read the directions, factor. Have fun. Factoring is fun.